Hi student, how are you? I hope you are doing well. Welcome back to my channel. This channel is dedicated to helping you enhance your understanding and skills in mathematics. My goal is to provide a supportive and engaging learning environment so we can explore, discover, and solve problems together. Today we are going to explore a new topic, the nature of roots of quadratic equations. But what exactly do we mean by the nature of roots? When we consider a quadratic equation in the form ax squared plus bx plus c equal to 0, the nature of its roots describes the characteristics of the solutions to the equations. Specifically, a quadratic equation can have one of the three different types of roots. The first one, two distinct real roots. The second one double real root. The word double refers that originally there are two roots, but these two roots are identical in this particular equations. And the last one is no real roots. You may notice that the term real preceding the word roots. Roots can be classified as either real or complex. At this point, we haven't yet covered the real number system, so you might not understand the necessity of specifying the roots as real. However, we will explore these distinctions in later episodes. But before I explain why, I encourage you to take some time to review the examples and try to figure out the difference by yourself. Perhaps I highlight some key points for you to focus on. Okay, in the first example, roots positive 16, and then the second one is root 0. The last one root negative 4. Because inside the square root sign is very crucial. Do you know why? Okay, now the first one, root a positive number. Then the next step, you can separate into two different roots. One, negative 2 plus 4 over 2. The second one is negative 2 minus 4 over 2. So there are two different roots. Next example, root 0. Then you cannot write 12 plus 0 over 18 or 12 minus 0 over 18. Because they are the same. So in this case, you have only one repeated real root. For the last one, because the number inside the square root is negative, okay, in this case, you don't have any roots. So you can see that the sign of the number inside the square root determine the nature of root. We just mentioned the sign of the number inside the square root determine the nature of root. Now we recall the quadratic formula is negative b plus or minus root b squared minus 4ac over 2a. Okay, you see that the number inside the square root is b squared minus 4ac. This guy determines the nature of roots. Okay, so we define a new term. The discriminant of quadratic equations is defined by b squared minus 4ac. Some people use a symbol delta. This one is the 4 Greek alphabet. Okay, delta is equal to b squared minus 4ac, or we just simply use d is equal to b squared minus 4ac. A new term, the discriminant is equal to b squared minus 4ac. It single-handedly determines how many real roots the equation have. Okay, I prepared 5 examples to do. The first two are quite straightforward. Okay, let's see the questions. Find the discriminant of the following equations and determine the nature of roots. Okay, so we have two things to do. The first thing, we find the discriminant, and then the second one, we determine the nature of roots according to the result of the discriminant. Okay, the discriminant I write in the right hand side is equal to b squared minus 4ac, and if the result is bigger than 0, two real roots equal to 0, 1, and less than 0 will be no real roots. Okay, so the discriminant of number 1 is v square minus 4 times 2 times 8. Okay, so 9 minus 64. So the answer is negative 55. Okay, we need to mention that that is less than 0. And then according to the table in the right hand side, so the nature of words should be low, real words. Okay, the question 2, we need to simplify the expressions to a form ax squared plus bx plus c equal to 0. Okay, so 4x squared plus 2x minus 6x plus 1 is 0. 4x squared minus 4x plus 1 is 0. Okay, so discriminant is equal to b squared minus 4ac. b is negative 4 squared minus 4 times 1. Okay, so 16 minus 16 should be 0. So for 0, 1 double real root. Okay, question 3. Consider the quadratic equations 3x squared minus 3x minus 2k is 0. Okay, part A, express the discriminant in terms of k. In part A, we just simply recite the discriminant. Discriminant is b squared minus 4ac. So negative 3 squared minus 4 times 3. C should be negative 2k. Okay, simplify it. 9 plus 24k. Okay, in part B. Find the value of k if the equation has one repeated root. Okay, we recall the nature of root. Discriminant bigger than 0, 2 real roots, equal to 0, 1, less than 0, no real roots. Okay, in this part, we are given the equation has one repeated root, so there's this case. So we are given in this part, discriminant is equal to 0. So 9 plus 24k is 0. So k is less than 9 over 24. Okay. Part C, find the range of k if the equation has real roots. The most important thing of this part is has real roots. Okay, has real roots. Has real root refers to has one real root or two real roots. Okay, so combine these two things. The discriminant should be bigger than or equal to 0. Okay, so the information given by part C should be the discriminant bigger than or equal to 0. So we put 9 plus 24k is bigger than or equal to 0. In this part, we are required to find the range of k. So we just simply move 9 to the right hand side and divide it by 24. So the range for k should be 9 over 24. For the quadratic equation so and so has two unequal real roots. Find the range of m. Okay, has two unequal real roots. Obviously, it tells us that the discriminant is bigger than 0. We need to simplify the equation before we plug in the formula of the discriminant. Okay, x squared plus 2x plus m. Okay, minus 6s minus p is 0. Okay, so x squared minus 4s. Constant remains should be m minus p. I use a bracket to contain the constant. Okay, so a is 1, b is negative 4, and c is m minus p. Okay, so by the question, we know that the discriminant is bigger than 0. In the ABC, in the formula of the discriminant, negative 4 square minus 4 times 1 times m minus v is bigger than 0. We try to simplify the inequality and get the range of m. Okay, 16 minus 4m minus 12 is bigger than 0. Okay, 4 minus 4m is bigger than 0. Okay, move negative 4m to the right hand side. Okay, we put m to the left hand side. We just flip-flop the inequalities. So we have the final answer, m is less than 1. Okay, the quadratic equation had real roots. Part A, find the range of the values of k. Okay, once again, the question tells us that this equation has real roots. Okay, had real roots include one real root or two real roots. Okay, so obviously, once again, discriminant is bigger than or equal to 0. Okay, in part A, we just write this step first and then put in the ABC into the inequalities. Okay, A should be 2k minus 1, B is negative 6, and C should be 3. So negative 6 square minus 4 times 2k minus 1 times 3 is bigger than or equal to 0. Okay, 36 minus, combine these two numbers to be 12. So 24k minus, should be positive 12, bigger than or equal to 0. Okay, move 24k to the right hand side, 48. So 2 should be bigger than or equal to k. Usually we put the unknown in the left hand side, so k is less than or equal to 2. Okay, part B, when k takes up the maximum value in the range found in A, solve the equations. Okay, in part A, we have the range of k. We try to test up the maximum value of k. Okay, in part A, we know that the value of k should be less than or equal to 2. Okay, so the range of 2 should be the left hand side of 2. The questions asks us to find the maximum value of k. Okay, the maximum obviously should be 2. Okay, we take the values of k as 2. Substitute k is equal to 2 back to the quadratic equations. So the equation becomes 3x squared minus 6x plus 3 is equal to 0. Okay, we divide the whole equation by 3. Okay, this one is obviously s negative 1 negative 1. Okay, so x minus 1 square is 0. So the answer s is equal to 1.